Section 3.4, we're solving more inequalities. All right, so in this lesson, again, we're going to continue to solve some of these linear inequalities. Again, we're going to graph a solution to the linear inequality on a number line. We've talked about already that when it comes to solving these inequality problems, you're going to follow the same steps that we did when solving equations. Step 1 is to clear out fractions. Step 2 is to simplify each side of the symbol. So here again, we have opportunities here to simplify the left and the right side by distributive property. All right, so on the left side, when we distribute that 3, we get 6x minus 12. And then on the right side, when we distribute that 2, we get 6x minus 12. Okay, so now we want to go ahead and undo the operations. So maybe I want to bring my variable over to the left. So the one on the right, we want to get rid of. So we're going to subtract 6x here to get rid of it. And what we do to one side, we have to do to the other. So on the left side, we have 6x minus 6x, which is 0. So that gives me a negative 12. On the right side, I have 6x minus 6x, which is again 0, leaving me with a negative 12. So here we find ourselves trying to solve for x in this inequality, and the variable goes away. Now, we've seen this scenario when we were solving equations in Unit 2. What did we do when the variable went away? Well, we thought about it and talked about it and said, hey, this is one of those special situations where it's either going to end up as no solution or infinitely many solutions. And the way we determine that is by looking at what statement is left when the variables disappeared. Here we're left with negative 12 is less than or equal to negative 12. So now if we're looking at this symbol in between, negative 12 is not less than negative 12. But we do have in this particular inequality the or equal to option. So therefore, this negative 12 less than or equal to negative 12 for us is a true statement. So what does that mean in terms of our solution for this inequality? All right, so please note what I wrote on the solution line, and you make sure you write the same thing. Again, we went in trying to solve for x. The variable disappeared, and we were left with a statement that we said was true. And so what does that mean for our solution for x? X can be any real number, which means x can be any number, and it's going to work. So now we need to know how we're going to write that answer as an interval notation and how the graph is going to look. Well, let's start with the graph. Again, we said that x can be any number. So that means with respect to the number line, this is the way that we're going to graph that concept. The entire number line is going to be shaded. Because again, x can be any number. So now, how do we write that as an interval notation? Well, again, you notice that on the left side of my graph, we have the big old arrow going towards the left. On the right side of my graph, I have the big old arrow going to the right. If you think about how we wrote that in interval notation, then it would make sense when we say that interval notation is negative infinity, comma, positive infinity. And so negative infinity, comma, positive infinity is the interval notation for our graph, which again is communicating that x can be any number for this problem. All right, moving on to number 2. Again, we want to solve this inequality for x. So again, we want to clear out fractions. We don't have any. So now we want to go ahead and simplify each side. We distribute the 2 through the parentheses. We get 2x minus 8. On the right side, we have 2x plus 1. So now again, we want to undo operations. I got variables on both sides, so I want to get all the x's over to the left. So on the right, I want to get rid of this 2x, so I'm going to do the opposite. I'm going to subtract it away. And when I do the one side, I have to do to the other. On the left, I am left with negative 8 because 2x minus 2x is 0. Here's my inequality symbol. It's a greater than. On the right side, I have 2x minus 2x, which again is 0, leaving me with a 1 on the right side. Here again is the situation where the variables disappeared. And I'm left looking at a statement that's telling me that negative 8 is greater than 1. Negative 8 is not greater than 1. That statement is false. So what does that mean for our solution? It means that there is no solution, right? Again, this situation, in trying to solve for x, our variable disappeared, and we were left with a statement that we know is not true. That's telling us that there is no solution. So now when it comes to problems like this on a quiz or test, right, and if you have like an answer line here for interval notation, you can go ahead and write the word none. So that's telling me that you're telling me that there is no interval notation for no solution, which makes sense. In terms of a graph, right, just tell me there's none. There's nothing that we can do to graph because there is no solution. All right, moving on to the next page. Let's go and get some more practice with solving these linear inequalities. Let's take a look at number 2. Again, we want to solve that for x. So again, we start off by subtracting 6x from both sides, and then adding 5 to both sides, and then getting x by itself by dividing both sides by negative 9. Now again, because we divided by a negative, notice how the inequality symbol flipped, right? We started off with a less than or equal to symbol, but because we divided by a negative 9, that less than or equal to symbol flipped into a greater than or equal to symbol. So we have x is greater than or equal to negative 2. All right, so now we want to go ahead and write it in interval notation. All right, so again, we are looking for x values which are bigger than or equal to negative 2. So we draw our number line. We're only interested in negative 2 for our graph. So I'm going to go ahead and put a closed circle on negative 2 because we have the or equal to. Again, we're looking for x values which are bigger than, so that means we need to shade to the right. We want to do interval notation. All right, so right above, I'm going to put a squared off bracket next to a negative 2. That is on the left. Then on the right, it goes to positive infinity. So there's my infinity symbol. And again, always parentheses right next to an infinity symbol. All right, skipping over to number 6. Again, get some more practice with fractions. We want to clear out these fractions first. So we're going to go ahead and multiply by 2. Every term gets multiplied by 2. So I'm left with 8. These 2's cancel here. Minus 3x less than 26. undoing operations. We're going to subtract 8 from both sides. And again, undoing operations. We're going to divide by negative 3. So we're left with x is greater than negative 6. Because we divided by a negative, that inequality symbol flips. It goes from a less than in the original problem to a greater than symbol. Graph it on a number line. Let's find negative 6. Open circle this time. X is greater than. So again, we're going to shade to the right. Interval notation. Starting off on the left with a parentheses because we have an open circle next to the negative 6. Comma. Going to the right forever. That's positive infinity, again with a parentheses next to infinity. All right, I'm going to skip all the way over to problem number 15. Number 15 on page 23. Again, we want to solve this inequality. Right, the left side looks pretty simplified. That right side, again, we got some work to do. So again, we talked about before that when you have these grouping symbols, you want to work your way inside out. So looking inside the brackets, we see x plus 2 minus 2x. So that's what we want to simplify first or do first. So I have x and then negative 2x is negative 1x, then plus 2. So again, that's inside the brackets. All right, so now we want to expand a little bit further outside the brackets. So we're going to go to the 3. So I'm going to bring that 3 over. So now I'm seeing 3 next to a grouping symbol. So I want to go ahead and distribute. Negative 3x plus 6. So the only thing I have left now is to take care of that negative 1. So I'm going to bring that negative 1 down. So I'm going to simplify negative 3x, and then 6 minus 1 is 5. All right, so there's the right side as simplified as it's going to get. Let me bring down that inequality symbol, that less than symbol. Let me bring down the left side of 3x plus 1. All right, so now with both sides simplified, let's go ahead and solve for x. All right, so bringing my work over here to the right. Again, I see I have variables on both sides of the inequality. I want to bring everything over to the left. So over here, I'm going to get rid of this 3x by adding 3x. And when I do the one side, I have to do the other. So on the left, I have negative 3x plus 3x, which is 0. So I'm left with a 1. On the right side, I'm left with negative, I got 3x and a negative 3x, which again adds up to 0. So now I'm just left with a 5. Here again is one of those special situations where the variables disappeared. Now I'm left with a statement that says 1 is less than 5. Right. Again, because that is a true statement, we know what the solution for x is going to be. X is any real number. And I've talked about it before when it comes to quizzes and tests. Right? You need to make sure your work reflects what we are doing in class. This is the answer I'm looking for a situation like this. When your variables disappear and you're left with a statement that is true, I'm not looking for the word true. I'm not looking for a 1 or a 5. I'm looking for this. X is any real number. When it comes to interval notation, I'm looking for this. Negative infinity, comma, infinity. And when it comes to a number line, you are shading the entire number line. All right, so again, for a situation like this, this is the expectation when it comes to your responses. All right, that's it for this lesson. Go ahead and move on to the 3-4 homework.